All right, so this is Unit 5, Lesson 2, Simplifying Exponential and Radical Expressions, okay? So, all right, when we are simplifying radical expressions, and just remember, when it says radical, you should usually see this symbol right here. This is called a radical. We want to make sure that the expression inside the radical, meaning whatever is underneath here, is as small as possible without decimals. Okay, so you see there's a big number here, 252. We want to simplify it so that it has a smaller number than 252 underneath the radical. But at the same time, these two things right here, this expression is equivalent to this expression down here, like how I have here. They're equal to each other, but this is, we call this a simplified expression, and I'm going to show you the process to do that. All right, so the first example, it says that let us simplify square root of 252r. We start by finding all the prime numbers that are under the radical. The easiest way to do that is the factor tree. So we start with 252 and we factor it out, okay? And then this part, when we're after we have done the factor tree, to simplify it, we take out factors from under the radical according to its root. Okay, so whenever you have the symbol square root, you know that there's a 2 here. This is your root. The number over here, we call this the root. Okay, according to the root. So if the root here is 2, so for every 2, we take it out of the radical because of the square root. So for every 2, we take 1 out of the radical. Since there's only 1 7, we leave it under there. Since there's only 1 r, we leave it under here. And then we simplify. Where was I? Sorry. Okay. So now we just combine these two together. 2 times 3 is 6. That's where this came from. And then the square root. You don't have to always write this the 2 up here. We don't write it. So let me take that off. And then just put everything else back underneath the radical. So this right now is a simplified version. Okay? All right, so sometimes we have expressions that are not just square root, but they might be cube root, or you can have fourth roots, fifth roots. But this root is an important number because it tells you how many you can take out of the radical depending on the root. Okay, so here's this example. You can go through, but I do want to go through some that haven't been done yet. Okay, so over here, this is a cube root, but we start by factoring it out. Okay, so we look at 16, we're going to factor that out. I know 4 times 4 is 16, or you could have done 2 times 8, it's all the same. And then 4 is 2 times 2. This 4 is 2 times 2, and then 5 cubed, you can say x times x times x times x 5 times. And then now I'm going to bring the cube root out. Cube root down. Okay, now here's that. Well, this is the fun part. I don't know, it's fun for me. For now, depending on the root, okay, for every 3, one of them comes out. Let me write this a little better. Okay, so for every 3, since this is a cube root, every 3, one of them comes out. Okay, this 2 stays under here, but I can take out some x's. For every 3, one of them comes out. And then we just simplify this, the cube root, and then you have whatever you left under here. You have the 2, and then you have the x and the x. Okay, now let's rewrite this answer to make it look pretty. So you have 2 times x, which is just 2x, and then you still leave the cube root, because if it's a cube root, you got to leave this 3 up here. You can't just take it out. The only time we don't write it is if it says square root. And then you have 2x squared. So this is my answer right here. Okay? 2x, where is it? Oh, it's right here. Okay? Let's try square root here. So this 2 out here, you leave it, just there's nothing to take out because it's already out of the radical. Remember, this is a square root, but before I do that, let me start factoring this out. I'll do 2 times, what's that, 32? And then 32 is, yes, I am taking out my calculator. I am not, oh man, I can't find my calculator. There it is. So you have here, where does 32 go? I think 4 goes into 32. Yep. 4 times 8. 2 times 2. This is 4 times 2. And then 2 times 2. Okay, so now let me just keep track of it. You have here negative 2 from here, and then you have the square root of 2, 1, 2, 3, 4, 5, 6 2's. Okay, and then you have 3 x's. All right, the fun part. So this is a square root, so you know that there's a 2 up here. So that's your second root. So for every 2, one of them comes out. For every 2, one of them comes out. Another one comes out. An x comes out. Okay, and then I had this negative 2 from the problem. I put it in parentheses because I don't want it to look like x minus 2. And then you have the x here. Now put everything back together. 2 times 2 is 4. 4 times 2 is 8. 8 times negative 2 is negative 16x square root of x. Okay, so that is my answer. It's got to be in here. Oh, there it is. Okay. Let me do one more. Maybe I'll do this one. There's a negative, it's a fifth root, there's a number out here. I think we can do this one. So you have the 7 out here. And then before, well, I don't want to do all that. Let me do the factor tree first. So 64, that is 64. Let me see, 4 goes into it. Yeah. So that is 4 times 16. 2 times 2. 16 is 4 times 4. And that's 2, 2, 2, 2. Okay. Alright, so let me write all this out. I'll do it in green pen. So we have here, actually, so I just kind of moved it over. That's all I did. So you have here, you have the 7, and then you have your fifth root. That's important. Don't take out that 5. And then you have negative 2, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then, is that it? Yep. And then you have a to the 8th power. I'm not going to really write that many a's, but you know that you have 8 a's. Let me deal with that in just a second. All right, so it says here, so for every 5, one of them comes out. Actually, let me, I guess, just write it out. 1, 2, 3, 4, 5, 6, 7, 8. So for every 5, one of them comes out because this is a fifth root. So 1, 2, 3, 4, 5. For every 5, 1, 2 comes out. Okay, let me bring down the 7 from up here. And then for every 5, 1, 2, 3, 4, 5, one of them comes out. And there's nothing else I can take out. So now I'm going to put the fifth root of and stick whatever else I have underneath there. There's a 2 here, and then there are 3 a's, so a cubed. So 7 times 2 is 14. A fifth root of 2a cubed. Okay, and you know you have simplified this, and well, there you go. Let me see if I can find the answer. A to the fifth, blah, 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 blah. It's right here. Oh, the negative. Yep, the negative didn't come out. Okay, so there you go. That worked. Alright, so the second part of this, I'm just going to give you the notes on this, and I'm going to go through some examples. When we are simplifying exponents, in the previous examples we had radicals. Now when you're simplifying exponents, we want the expression not to have a fraction in the exponent. Okay, so in the end, we want it to look something like this. Okay, this expression right here is the same as this expression right here. Oh, I have it right here. Okay, this is a simplified expression. All right, so the first step is to distribute the exponent. Okay, I did that here. I took the 3/2, I distributed it to the 25, and then the 3/2 and distribute it to the x. And what that happens is you multiply the exponent. So 1 times 3/2 is you just get 25 to the 3/2, and then 2 times 3/2 I get 3. Okay, and then the step 2 is check to see if the exponent has a bigger number in the numerator than the denominator. Okay, so you're going to check the exponent. This one's already done. Okay, this one's simplified. There's nothing I can do. But over here, if you notice, 3 is bigger than the 2. So we can manipulate the exponent so that you can reduce part of the exponent to 1. What that means is, so over here, what I did was I took, I have the 2 here, so I took 2 out of 2, put it by itself, and then put 1/2, because 2 plus 1 gives you your 3 back, and then you have your 2. What happens when you do that is 2 over 2 gets reduced down to 1, and then here you have 2 to the 1/2, and remember that 1/2 is the same thing as a square root, so you have 25 to the first power, which is 25. Square root of 25 is 1, and then you bring down the x cubed. And then 20 times 5 is 125x cubed. Okay, so let me go through some examples. Alright, so I'm going to first distribute the exponents. Okay, so I'm going to do, hang on, let me get a, so 1/2 times 64, so you have 64 to the 1/2, and then you have x 1/2 to the 4, so 4 times 1/2, that is 2. Alright, this part's already reduced, and here I can't really change anything because the number in the numerator is smaller, but I do know that 64 square root of 1/2, I can change it to the square root of 64 times x squared. Square root of 64 is 8, I think. Hold on. Yes. And then you have x squared. To make it look pretty, I'm just gonna write it as 8x squared. Okay. Same thing here. Now you have a negative exponent. So to make it this, hang on. Okay. So whenever you have a negative exponent, whenever we're simplifying, these are not exponentials expressions, we don't want to not only have an exponent in the exponent or a fraction in the exponent, we also don't want to have a negative. So whenever you have a negative exponent, you have to rewrite this as, you're going to put a 1 over, you're going to put everything in the denominator, and that makes the negative go away. Okay, 3 over 2. Okay, you just take everything and put it in the denominator. Next, you're going to distribute the exponent. Okay, so you have 1 over, so 36 to the 3/2, and then x to the 6 times 3/2 is 6 times 3 is 18 divided by 2, that is 9. Okay, 6 times 3/2, this is what I did, 6 times 3/2, that's equal to 6 times 3 is 18 divided by 2 is equal to 9. That's where I got this 9 from. Okay, so and this 1 stays over here. All right, so now if I look over here, let me look at 36 to the 3 halves. Okay, the numerator is smaller, so which means that I can rewrite it to look like this: 36 2 over 2 times 36 to the 1 half. 36 2 over 2, that's just 36 to the first power, which is equal to 36. And then here, 36 to the 1 half, that is the same thing as square root of 36, which is equal to 6. Alright, so you have here 1 over all of this is equal to 36 times 6, which is 36 times 6 is 216. 216 x to the 9th power. That's my answer. Better be down here. Oh man, there's no 9 here. Well, it's supposed to be 9 here. Okay. What else? I think I'll stop here and let me know if you have any questions.